Hello students, welcome back to my channel. My name is Miss Amandeep Kaur. So I am back with maths topic complex numbers. So these are some useful results of conjugate, argument and modulus. Let's start from conjugate. So first result is double conjugate of z is equal to z, where z conjugate is conjugate of z. Second, z plus z conjugate, that is equal to 2 times real z. Third, z minus z conjugate, that is equal to 2 times imaginary z. Fourth, if z is equal to z conjugate, then z is purely real. Fifth, if z is equal to minus of z conjugate, then z is purely imaginary. Sixth, z into z conjugate is equal to modulus z square, that is equal to real z square plus imaginary z square. Seventh is z1 plus minus z2 conjugate, that is equal to z1 conjugate plus minus z2 conjugate. Now eighth is z1 into z2 conjugate, that is equal to z1 conjugate into z2 conjugate. Ninth is z1 by z2 conjugate, that is equal to z1 conjugate by z2 conjugate, where z2 not equal to 0. Now modulus, first modulus of z, that is equal to modulus of z conjugate, that is equal to minus of z modulus, that is equal to minus of z conjugate modulus. Second, minus z modulus less than equal to real z less than equal to z modulus. Third, minus z modulus less than equal to imaginary z less than equal to z modulus. All z belongs to complex numbers. Fourth, z1 by z2 modulus, that is equal to z1 modulus by z2 modulus, and z2 not equal to 0. Fifth, z raised to power n modulus, that is equal to z modulus raised to power n. Sixth, z1 plus minus z2 modulus all square, that is equal to z1 modulus square plus z2 modulus square plus minus 2 times real z1 into z2 conjugate, that is equal to z1 modulus square plus z2 modulus square plus minus 2 z1 modulus into z2 modulus into cos theta 1 minus theta 2, where theta 1 is argument z1 and theta 2 is equal to argument z2. Seventh, z1 into z2 conjugate plus z1 conjugate into z2, that is equal to 2 times z1 modulus into z2 modulus cos theta 1 minus theta 2. Eighth, z1 modulus minus z2 modulus less than equal to z1 plus minus z2 modulus less than equal to z1 modulus plus minus z2 modulus. Now argument, the principal value of argument z is alpha, pi minus pi plus alpha and minus alpha, as z lies in first, second, third and fourth quadrants respectively. First, argument z1 into z2 is equal to argument z1 plus argument z2. Second, argument z1 by z2, that is equal to argument z1 minus argument z2. Third, argument of z conjugate is equal to minus of argument z. Fourth, argument z by z conjugate is equal to 2 times argument z. Now fifth, argument z raised to power n is equal to n times argument z. Sixth, if argument z is equal to 0, then z is real. Seventh, if argument z2 by z1 is equal to theta, then argument z1 by z2 is equal to 2k pi minus theta, where k belongs to I, means integer numbers. 8. Z is equal to r into e raised to power iota theta, that is equal to r into cos theta plus iota sin theta, where r is the modulus and theta is the argument of z. Right? Let's take example 1. The modulus of the complex number z such that modulus of z plus 3 minus iota, that is equal to 1, and argument z is equal to pi is equal to. So let's start. First, let z is equal to x plus iota y. Right? Now let's start. Modulus of x plus iota y plus 3 minus iota, that is equal to 1. Now modulus is equal to x plus 3 whole square plus y minus 1 whole square under root that is equal to 1. Now squaring both sides, we will get x square plus 9 plus 6x plus y square plus 1 minus 2y that is equal to 1. Now we are given that argument of z is equal to pi. Now argument z is equal to pi, then now we know argument is minus of imaginary part by real part, that is equal to tangent pi, which is we know 0. But x cannot be equal to 0, right? So this gives us that y is equal to 0. Now we will put this value of y in this equation. We have the equation x square plus 9 plus 6x plus y square plus 1 minus 2y that is equal to 1. Now just put y is equal to 0. We will get x square plus 9 plus 6x plus 1 that is equal to 1. 1 will get cancelled. So we have x plus 3 whole square that is equal to 0. This gives us x is equal to minus 3. Now z is equal to, now we know that the imaginary part is 0, y is 0, then z equal to minus 3 and modulus of z is equal to positive 3. So this is the answer. Now let's take example 2. If z1, z2, z3 up to zn are complex numbers such that modulus of z1 that is equal to modulus of z2 up to so on zn modulus that is equal to 1, then modulus of z1, z2 plus up to so on zn is, now let's start solving this sum. Now z1 modulus z2 modulus up to zn modulus that is equal to 1. This is given, right? Now squaring all, right, we will get z1 modulus of z2 square up to so on modulus of zn square that is equal to 1. Reason that z into z conjugate is equal to modulus of z square. Now we will put this in the equation. z1 into z1 conjugate that is equal to z2 into z2 conjugate that is equal to up to so on zn into zn conjugate that is equal to 1. From this we will get that z1 conjugate is equal to 1 upon z1 and z2 conjugate is equal to 1 upon z2 up to so on zn conjugate is equal to 1 upon zn. Modulus of z1 plus z2 plus up to so on zn that is equal to z1 plus z2 plus up to so on zn modulus and whole conjugate. So because modulus of z is equal to modulus of z conjugate, so this gives us that modulus of z1 conjugate plus z2 conjugate plus up to so on zn conjugate, and this is equal to modulus of 1 by z1 plus 1 by z2 plus up to so on 1 by zn, and this is the answer. Now example 3 is if z is equal to r into cos theta plus eta sin theta, then value of z by z conjugate plus z conjugate by z is. So first of all let's write, and this given is equal to r into e raised to power eta theta by r into e raised to power minus eta theta plus r into e raised to power minus eta theta by r into e raised to power eta theta. E raised to power eta 2 theta plus e raised to power minus eta 2 theta, right? Now e raised to power eta 2 theta, that is equal to cos 2 theta plus eta sin 2 theta, right? Now e raised to power minus eta 2 theta is equal to cos of minus 2 theta plus eta sine of minus 2 theta, right? Now on adding these both, we will get cos 2 theta plus eta sine 2 theta plus cos 2 theta, because cos of minus theta is equal to cos theta, that's why. Now sine of minus theta is equal to minus of sine 2 theta, which is equal to 2 cos 2 theta. So this is the answer. The number of solutions of the equation z square plus z conjugate, that is equal to 0 is, now let z is equal to x plus iota y. Now x plus iota y square plus x minus iota y, that is equal to 0. On solving this, we will get x square minus y square plus 2 iota xy plus x minus iota y, that is equal to 0. Separating real and imaginary part, we will get x square minus y square plus x plus iota into 2x minus 1y, that is equal to 0. From this we will get two equations. First is x square minus y square plus x, that is equal to 0, and second equation is 2x minus 1 into y, that is equal to 0. Now from equation 2, y is equal to 0 and x is equal to 1 by 2. Put these values in equation 1, right? So first x square minus y square plus x, that is equal to 0. Put y is equal to 0. We will get x square plus x is equal to 0, which gives x into x plus 1 is equal to 0. This gives us x is equal to 0 and minus 1. Now put x is equal to 1 by 2 plus 1 by 2 square minus y square plus 1 by 2, which gives us y square is equal to 1 by 4 plus 1 by 2, which gives us y is equal to plus minus under root 3 by 2, right? Now number of solutions are 0, 0, minus 1, 0, 1 by 2, under root 3 by 2, and 1 by 2 and minus under root 3 by 2. So these are 4 solutions. Now example 5, modulus of 1 by 2 into z1 plus z2 plus under root z1 z2 plus modulus of 1 by 2 into z1 plus z2 minus under root z1 z2 is equal to, so now 1 by 2 into modulus of under root z1 plus under root z2 whole square and plus 1 by 2 modulus of under root z1 minus under root z2 square, right? Now this is equal to 1 by 2 modulus of under root z1 minus under root z2 square plus 1 by 2 into modulus of under root z1 minus under root z2 whole square. Under root z1 modulus square plus under root z2 modulus square, right? And this is equal to z1 modulus plus Z2 modulus. So this is the answer. Now example 6. If 5z2 by 11z1 is purely imaginary, then value of 2 into z1 plus 3z2 by 2z1 minus 3z2 modulus is equal to. So let 5z2 by 11z1 that is equal to iota y, because this is imaginary, right? Now z2 by z1 is equal to 11 by 5 iota y. Now this is 2 into z1 plus 3 z2 by 2 into z1 minus 3 z2. Here let's take z1 common, right? So this is equal to 2 plus 3 into z2 by z1 by z1 into 2 minus 3 z2 by z1 modulus, right? Now z1 will get cancelled. So now we have 2 plus 3 into 11 by 5 iota y by 2 minus 3 into 11 by 5 into iota y. We have put the value of z1 by z2 and modulus 2 plus 33 by 5 iota y by 2 minus 33 by 5 iota y. Now this is equal to 1 because numerator is the conjugate of denominator, right? So their modulus are equal, right? Now example 7. Modulus of z minus 25 by z minus 1 is equal to 5. Then value of modulus of z is equal to. So let z is equal to x plus iota y. Now let's put x minus 25 plus iota y by x minus 1 plus iota y, right? This is equal to 5. Now x minus 25 square plus y square, right, by x minus 1 square plus y square, this is equal to 25, right? Squaring. Now x square plus 625 minus 50x plus y square, that is equal to 25 into x square plus 1 minus 2x plus 25 y square. Now here let's solve. X square plus 625 minus 50x plus y square, that is equal to 25 x square plus 25 minus 50x plus 25 y square. Here minus 50x will get cancelled. 24 x square plus 24 y square minus 600, that is equal to 0. Now taking 24 as common, we have x square plus y square minus 25, that is equal to 0. Now x square plus y square minus 25, that is equal to 0. X square plus y square, that is equal to 25. Now take under root both sides, we will get, this is modulus of z, that is equal to 5, right? So this is the answer. Let's take next example 8. For any two complex numbers z1 and z2 and any real numbers a and b, this statement is equal to square of modulus of a into z1 plus square of modulus of b z2 minus 2ab modulus of z1 into modulus of z2 plus square of modulus of b z1 plus square of modulus of a z2 plus 2ab into modulus of z1 into modulus of z2, right? Now a plus b into modulus of z1 square plus a plus b into square of modulus of z2, and this is equal to a plus b into modulus of z1 square plus modulus of z2 square. So this is the answer. Amplitude of 1 plus iota under root 3 by under root 3 plus iota is, first let z is equal to 1 plus iota root 3 by under root 3 plus iota. Now rationalizing this number, we will get 1 plus iota root 3 by under root 3 plus iota multiply by under root 3 minus iota by under root 3 minus iota, and this is equal to under root 3 plus iota by 2. Now amplitude of z is equal to tangent inverse of imaginary part by real part, right? That is equal to 1 by under root 3. So this is equal to pi by 6. So this is the answer. Now next example, if z1 z2 are two complex numbers satisfying z1 minus 3 z2 by 3 minus z1 into z2 conjugate modulus is equal to 1 and modulus of z1 not equal to 3, then modulus of z2 is, now let's start, z1 minus 3 z2 modulus, that is equal to modulus of 3 minus z1 into z2 conjugate, right? Now squaring both sides, we will get square of modulus of z1 plus 9 into modulus of z2 square minus 6 into modulus of z1 into modulus of z2, that is equal to 9 plus modulus of z1 square into modulus of z2 conjugate square minus 6 into modulus of z1 into modulus of z2 conjugate, because modulus of z is equal to modulus of z conjugate. So from here modulus of z2 conjugate is equal to modulus of z2, so these will get cancelled. Now modulus of z1 square minus modulus of z1 square into modulus of z2 square, that is equal to 9 minus 9 into z2 modulus square, right? So from here let's take z1 modulus square as common, so this is 1 minus modulus of z2 square, that is equal to, let's take 9 common, now 1 minus modulus of z2 square. So from here modulus of z1 square is equal to 9. This gives us modulus of z1 is equal to 3, but this is not equal to 3 because this is given that z1 modulus not equal to 3. Now let's take 1 minus modulus of z2 square is equal to 0. This gives us modulus of z2 square is equal to 1 and modulus of z2 is equal to 1. So this is the answer we have done. Thank you so much for watching this video.